So some of you may know that I have been trying to figure out the Ender 3 V3 SE, and I don't say that as a beginner. Of course, I'm by no means an expert either, but there are many ways that I'm figuring it out can be taken. I have made a video in the past saying how to level your Ender 3 V3 SE, and what's on the video isn't wrong. It's the way that Creality's support told me to fix the auto-leveling in at least 2 separate support threads. But that's not really fixing the problem, is it? I guess it depends on what you think the problem really is. If you only think that getting the bed leveled and printing properly is the problem, then sure, it's probably the solution. But I wasn't happy with it. Even after getting decent prints, and believe me, I would probably go back in time if I could to get those first layers back again. But to me, the problem wasn't just the first layers themselves, it was that the machine couldn't get them itself. Someone told me in the comments on one of my videos that the leveling isn't meant to be perfect, but there's no reason for it not to be. I've told this small story before, but after installing third-party firmware on my Ender 3 V2, it got perfect first layers basically every time with its BL Touch. That is on hardware that was not even originally designed to have auto-leveling, and it works better than this one which solely relies on it. That just doesn't add up to me. Unfortunately, I will warn you that the current conclusion to these experiments aren't good, at least not in my situation. But that doesn't mean that you might not have better luck. But another warning is that by trying to improve the printer, you could be making it worse, or you may have to do more work to get it back the way it started. So just be careful, and I'm not responsible for your actions. So this idea started with the idea to actually fix the printer, and the working video title being Testing Fixes from Reddit, or something like that. Well, shortly after doing the research for that video and going to put them into action on film, I got an intriguing comment on one of my earlier V3 SE videos. It was a comment saying a bunch of prerequisites you should do before expecting great results, especially if you are having issues. Honestly, at the time, I was kind of pissed that this guy posted this because it's basically what I had just been researching and was about to work on. Eventually, I came to the more logical conclusion to just put the list to the test, and that's what I attempted. I will admit, I don't follow the list exactly. They were numbered, so I assumed they were in an order, but some of them in that order didn't really make sense to me. I asked the video if they wanted to be mentioned and named in the video, and they said something along the lines of, make the video how you see fit. So to cover my bases, I will be hiding the name and profile of the viewer, even though they have already technically put themselves in the internet's line of fire. The comment was made on the video, How to Level Your Ender 3 V3 SE. The first suggestion made frequently is to tighten your bed screws. People coming from older printers like me might be confused when people say bed screws, because adjusting your bed screws used to mean turning the knobs at the bottom of your bed to manually level it and try and make it as flat of a surface as possible. What bed screws mean in this case is relatively similar but not exact. Under the build plate there are screws which keep the heated bed and plate secured to the moving chassis. These screws can come loose and cause issues for a few reasons, like disalignment and wobble. So you simply just want to tighten these down. To me, there's a simple point where the screws don't want to turn anymore, but they are more firmly in place. And that's exactly where you want them to be, at least as far as my knowledge goes. One person on Reddit went as far as to recommend a torque screwdriver. While it's possible this may give you slightly better results compared to manual torquing, I don't think it's going to be worth the $30 or more in terms of performance if you don't already have one. This step is effectively nullified by some of our next steps though, so just keep this one in mind. Another suggestion on Reddit is that when you do your auto-leveling sequence, that you should back out your filament from the hot end and clean off the nozzle. Now I don't know about the cleaning part, but backing out the filament might be a good idea. The idea behind both of these statements is if anything gets in the way of your auto-Z offset procedure, it will throw off your results. The auto-Z offset mechanism is why that corner where it does its adjustments is usually a bit higher than the rest in the leveling results. Because the mechanism underneath causes a height difference, and they didn't get the proper standoffs to make the bed actually level, though there are different size standoffs. But we will talk about that later. If I remember correctly, this component is a pressure gauge or something like that, and the bottom line is if plastic or anything else gets in between the nozzle and the plate, you'll have inaccurate results. Now, if you're going to clean the nozzle, of course, be careful. I clean the exterior of the heated nozzle with a paper towel that has been folded over a few times. This typically allows the plastic to attach to the towel, but the layers protect my fingers from the heat. Of course, do this with caution and put on work gloves or something for protection if you really need it. Additionally, it is effectively useless to clean the nozzle if you don't back out the plastic out of the hot end. Even if the printer doesn't try and actually push the plastic out of the hot end, it will still typically ooze leftover plastic out of it, just simply due to gravity or other pressures. Personally, I think it's useless to clean the nozzle manually unless it's really dirty. The Z offset process has a cleaning procedure to try and remove any plastic that is on or has oozed from the nozzle. Of course, this isn't a foolproof process, so do these steps if you feel it's necessary. The only thing I could add to this is to make sure the bed is clear of any debris. Unlike regular prints, minuscule things like fingerprints, oils, and fine dust shouldn't make a difference in the auto-leveling process, but plastic bits left behind from previous prints or levelings could get in the way. It's just a good practice in general to keep the bed in a clean state, major blockages or otherwise. The next suggestion from the viewer is to try and make physical washers/standoffs to compensate for a major bed tilt. But I think their next suggestion should come before that one, which is to level your x-axis. The axis the head moves along. It doesn't always come level from the factory. And if it's tilted, there can be all kinds of other issues with leveling and printing. The solution is simple as long as your bed is relatively flat and not majorly tilted. We'll talk about what that looks like later. So assuming your bed is decent, then get two solid objects of equal height to put on opposite sides of the bed. The official Creality video recommends glue sticks. Put them on the furthest possible ends of the x-axis for maximum accuracy, and bring the y-axis down manually with the printer turned off by twisting one of the lead screws. Both lead screws should turn when one has force applied to it. If that doesn't happen, you may have a completely different issue. If your X is level, then it should hit the tops of the glue sticks at the same time. You can check this by trying to move the glue sticks under the pressure of the x-axis bar. If one is tight and the other is loose, then you have an issue. I did not have my X out of alignment, so I will link the Creality after sales video for the rest of the adjustments, but luckily there aren't very many steps after this. As alluded to before, this method will not work if the bed does have a major tilt. Typically, the only time this will happen is if your stock standoffs are in the wrong positions. There are two sizes that come standard with the V3 SE. The shorter ones go on the left side with the weird stuff on top of the chassis, and the slightly taller ones go on the right side, which is all flat and normal. If you can't visually see the tilt with a level or the naked eye, then your bed is probably fine for this adjustment. So the next step would be the DIY standoffs. The good news for these is that they were one of the only fixes that actually helped my printer. These can be handled in a few different ways depending on how crafty you are or what other equipment you have, but I treated this scenario as if the V3 SE was my only printer and I had no other advanced skills. So let me take you through this process. Originally I started trying to do this process for all three lower corners, but I don't recommend it unless you are going to remake all the standoffs out of good material, or you find longer screws for the bed. I tried making standoffs for all points lower than the highest, so naturally the highest point was the front left. There are two reasons not to do it this way if you are sticking with stock equipment. One is that working with the back left standoff is really annoying, or at least I had one hell of a time trying to work with it. Trying to work with the standoffs as is one thing, but with having that plastic bit in the way and having the wires blocking and hindering the mobility and manipulation of the bed, it's just a real pain. The other reason is that the stock screws don't give you a lot of wiggle or adjustment room. The amount of excess thread is sparse, so you won't be able to make your standoffs very big. And in the case of the back left corner with that ring, the standoff can make it particularly difficult to get the screw back in the chassis or even impossible. So I recommend just trying to get the right side of the bed more level with the left. And as a pre-warning, it's probably not going to be perfect. So to start, you want to make a baseline level to know what you are working with currently. So let the leveling procedure go through and look at the results. I didn't do this personally, but I have noticed that the corners do shift slightly even between levelings done one right after another. So a more accurate measurement might be gotten by doing the leveling procedure a few times and getting the average of the corner values. Like I said though, I didn't do that. A small tip is to be careful with 0s and 8s when writing down data. I found myself writing the wrong numbers because they look so close on that screen. After getting your final data to take to the computer, make sure to press the cooldown button so it won't be hot when you come back to start working on it. So your next step is to take your measurements to CAD and design the simple parts. I have a video already recorded taking you through TinkerCAD, which is a simple CAD software designed to teach even children. So let's get right into that. They recommend doing this in a CAD software. This is one of the simplest CAD softwares that are available. It's available only through the website. It's called TinkerCAD, which is by Autodesk, which I think also makes like SolidWorks or something. But this is a much more simple version of any CAD software. It's meant for children, in fact. But adults can use it alike. We want to make a cylinder with a hole in it. So there is this little thing right here. However, it's hard to kind of measure what the inner circle is going to be because it only goes by this wall thickness. So you can't really know what the inner circle is going to actually be. So a better way to do this is to take your proper cylinder. I measured the standoffs that are already on the bed previously, and I have them written down here. So the rough estimates, or not estimates, the rough measurements of what I got was 7.8 for the outer ring. So you want this to be 7.8. And a way to make sure that it is exactly that is you put this little ruler tool on that corner dot. So now it's measured like so. So this is this total size of how it's supposed to be. So you just do 7.8 and then it gets all distorted until you go to this other side, which will then be 7.8. I put a slash in there. There we go. So this is our outer tube. Half of 7.8, this is an important thing, half of 7.8 divided by 2 is 3.9. Okay. So now we take one of these cylinders. Let's just make this easier. And we'll copy with Control C and Control V, and that'll be copy paste. We made another cylinder. Now the inner size needs to be 4 millimeters. So we make this 4 and make this 4. So an important thing that we need to do is we need to use midpoint on our ruler. And that is so that we can zero out everything and make it all centered. Okay, this is not going to work out the exact way, but when you zero it out, these are both inside of each other. Now we have put two solids in each other. This is not helpful because if we turn this into one object, it will just simply be a regular cylinder. And we did this with the merge tool. And if you merge something, you can unmerge it. Well, it's grouping and ungrouping. So we want to get this middle one and we want to turn it into a hole. So what this will do is anywhere where this hole geometry is, it will cut from any of the geometry around it as long as it's grouped together. So you gotta, click and slide so that you do the box select everything you want to group together, and then you simply hit group, and it cuts the hole. So that's nice and cool. And now this is where things get interesting, because now you have your thing. We're also gonna, it gives it a default name, just to make sure they're all different. We're gonna name this Ender 3 V3 SE Standoff. And I'm not going to put a size specifically because we're going to have to change it and then we'll export it and all that. So now we have to figure out how tall we actually need our standoffs. I didn't do this yet. One thing I don't know is what I should reference. So I don't know if I should try and standoff compared to the opposite corners or if I should do it to the same corners. So I don't know if I should do it side to side or diagonally comparatively, if that makes sense to anyone. I'm thinking diagonally is probably the way to go. But unfortunately, it still doesn't actually solve the solution because the objective is to try and get the bed the whole bed relatively flat. But the other problem is I really don't want to mess with that ring side because it's so obnoxious to try and do. Another thing to keep in mind is when I 3D printed these standoffs before, this 4mm ring was kind of small. It fit on, but then it would be very difficult to get off if I needed to, which is really frustrating because they would always fall off when I didn't want them to, but then when I wanted to take them off, they wouldn't come off. So we're going to make this a little bigger at 4.2. So hopefully that'll give it a little more room to wiggle and come off when we need to take it off. If we need to take it off, which we probably will. So we're going to try and go diagonally. So we need to find the difference between positive 0.29 negative and negative 0.63. So thinking about this, we're going to make this a little simpler to work with and get rid of some of the annoying complex numbers like the 9 and the 0.29. So we're going from a negative number to a positive. So what I'm going to do is I'm going to simply add 0.6 to just even out the negative number to 0, hopefully. And then we're going to add 0.3 because we have 0.29, which is very close to 0.30. So we're just going to go with 0.30, and we should have 0.9, yes. So yeah, we're going to go with that for the top left one, and I'm going to write it down so that I can put these in the right spot, hopefully. So then we have a relatively simple adjustment from the top left to the bottom right because we have negative 0.06 to negative 0.21. Now we're going to be printing these at a fine layer setting, which only allows us to do layers of 0.1. We might be able to do 0.15 if we really wanted to, but I think that 0.1 is going to be fine, and we're just going to do a layer of 0.2. So I hope that wasn't too awful confusing. I know I was kind of not being too awful helpful. So we're going to resize this, and just for the sake of ease, we're going to turn off use endpoint, or we're going to turn off use middle, because when it comes to this adjustment, it gets really frustrating because it will sink it into the ground. It'll sink it below the workspace here, which we don't want. So we turn it to use endpoint, so it's at 0, and all we have to do is adjust the proper size. This is about to get a whole lot smaller. Let's start with our big one, which is 0.9. Look at that, way small. So yeah, these are going to be small adjustments, and quite frankly, I don't know how much they're actually going to matter, which is why it's also really frustrating because there's not a whole lot of thread available for making major adjustments. So obviously a solution is to try and find the same screws and change those out. I don't know if that voids warranty or anything like that. I don't know if we have a warranty. I doubt it. Creality's kind of been stinky lately. But yeah. Let's save this. So we just simply press export. We do STL, and now it's downloaded into my downloads folder. So I'm going to move that to a proper area in my folders. So let me rename this to 0.90 because you don't want to have multiple files name the same thing, because then it will start to number it, which is a way to remember it, but it's much easier just to have the proper size labeled. But the download will be whatever the file name is in TinkerCAD. So you got to be careful with that, because if you're just changing the size, the file isn't going to account for that. The file name isn't going to account for that. It's just going to put it as whatever this is. So now we need 0.2, right? Yes. Bam. So this is going to be really small, and it's going to be 2 layers on the fine setting. It would be 1 layer on the normal setting, but we're going to do it on fine just to keep it simple and hopefully possibly more structurally sound. This is going to be really small, so it's going to be kind of hard to get off the plate and keep track of. So that's just something to be aware of. Additionally, this might show some issues if you have some vertical issues, because depending on your Z offset and all that, it may not print the proper thickness, but let's hope it does. If you have another printer that's more accurate, I would recommend probably using a different printer, but I'm going to try and print it on this printer for the sake of as if this was our only printer. So let's export this one again. Now we have our two files. Let's go into Creality Print. Now we have to go over here on our other screen here, and we're just going to simply box select and drag in both of these models. Let me get the OBS up so I can make sure you can see what you're seeing, see properly. So this one is in the center, so we need to move this one, the other one similarly. I mean, we don't need to, honestly, it doesn't matter, but let's just make it simpler for the machine. We'll move these a little bit closer to, if it would ever, there we go. All right, so now we have these two little things. We need high quality, because that is at 0.0, it's at 0.1. I believe I turned off auto brim on this, because I think it will make a brim. And I turned on the skirt, which I don't really need the skirt, so I'm thinking I'm going to turn that off. Also, it allows me to show you how it would be. So it's under build plate adhesion. This build plate adhesion type, normally it would be set to auto brim. I hate it. It's not useful. I mean, it can be useful, but most times people don't want brims. And most times you don't need brims, especially if you're working for PLA and you're using a heated bed. I have it set to skirt. I'm going to have it set to none, just to save a little bit of plastic and time and just try and get this done. There's always the pre-extrusion line unless you get rid of the G-code for it in the starting G-code, which I don't exactly remember how to do right now. And I don't know what line it is and all that. So, with that being said, if you're worried about the extrusion, the machine has that basically built in, or the code has it built in. But oftentimes it is useful to have the skirt. I'm going to turn the skirt back on, actually, because sometimes it stops retraction where it wasn't needed, so then it helps with certain things. Yeah, we're just going to go with skirt, and we're going to save that. And once again, the recording has messed up. Okay, so slice takes about 2 seconds, and as we can see here, okay, I was about to say something went wrong, but that's not the case. So we have 2 layers on this very minuscule thing. And this one we have 9 layers because 0.1 layers, 0.9 is 9 of those 0.1 layers. So even though the slicer shows this is only theoretical of what the optimal outcome would be. This is what it expects the printer to do, but it's not always what the printer can do. For this, obviously, it's a very simple print, but like I said, the vertical height might be a little bit off, which is what we really need here. So I'm going to export this to my SD card, and we're going to print this in just a little bit. So, like I said, it's a simple part. It's so simple, it wouldn't even be that hard to design in a real CAD software or more serious CAD software like FreeCAD, which is what I use for more serious designs. If you would like a short tutorial showing how to design the part in FreeCAD just as a beginner's tutorial, then let me know in the comments below. So after we have our standoffs 3D modeled, we need to print them out. Depending on your size, you may need to slice the model at a finer layer height so that they will print to the proper size. You should be able to print these out on your printer even with the way the printer is now, assuming your bed is put together, of course. These are so small that they're kind of hard to mess up. Though, like possibly said earlier, there may be some elephant's footing, so you may need to either model or slicer in some compensation. But I also mentioned in the video to make them bigger in general. But all of these are good things to look out for, of course. Wait for the models to print, they shouldn't take too long. You're probably going to need to wait for the bed to cool, especially if you're using a flexible build plate. These are so small that you're probably going to need a scraper or something similar to get them off the bed. Now that you have your models, they will most likely be different sizes, so keep track of which is supposed to go where. Now you have to unscrew the bed screws and have one of your spacers ready. Don't take the bed screws completely out from the bed. You will want to try and tilt the bed up while not messing up the other standoffs if possible. If your other right side standoff falls off, that is more manageable in my opinion than either of the left side standoffs, though the front left isn't very hard either. Once you have the right angle to work with, you want to get your spacer on the bottom of the stock spacer. So you want it on the side that would be touching the moving chassis rather than closer to the hotbed. You might be able to put your spacer on the top part of the stock spacer, but I wouldn't recommend it, especially if your spacers are printed out of PLA. PLA's glass transition temperature, or when it gets soft temperature, is 60 Celsius. Which also happens to be the most commonly used bed temperature for printing PLA, probably because of the glass transition temperature. And even if you printed them out of PETG, if I remember right, its glass transition temperature is up to 70 Celsius, which is what I use when I print PETG, because I usually have a little warping issues and I'm usually printing on smoother build surfaces. So now after you get your printed standoffs in place, you need to screw down and retighten your bed screws, reapply your bed, and do the level test again. The commenter says that you should have a maximum difference of 0.04 millimeters. That would be great, and if I put more effort into it, I might have been able to achieve these results, but I was so frustrated working on the bed, I thought my results were fine. I have about a 0.10 millimeter difference from the diagonal corners. The commenter doesn't say what should be leveled compared to what. I think they're just saying that you should level the entire bed. Now, I would agree with that in a perfect world, but because of the screws and such, it's a real pain and might not even be possible in some cases. If you aren't satisfied with your results, you need to go back to the CAD program and adjust your model's heights. Print new models, replace the spacers, put it together, and level it again until satisfied. We've talked a bit about this before, but if you have a mishap with the original standoffs where they fall off the bed and the screws, then make sure to measure them and put them back in their proper places. Half of my frustration was putting the bed back together when I was working on the 3 of the posts, and having the bed visibly majorly tilted. I didn't understand at the time until I contacted Creality support about a few of my issues, and of course only one issue was solved when they focused on the unlevel bed and said there are different sized standoffs. I thought they were all the same size and that's why the bed was unlevel by default, but I was obviously incorrect. So they put in the effort to use different standoffs, but not well enough to actually help level the bed. So there should be 2 shorter standoffs to put on the left posts, or the ones with the bed electrical protector ring, or whatever that is, and the pressure gauge assembly, or whatever that other thing is. Then there should be 2 slightly longer ones for the right side, which is a normal flat area on the bed chassis. So this is where the list kind of falls apart. I was having Z offset issues, or at least I thought I was, because of the elephant's footing. So in the middle of trying to make the standoffs, I also leveled the Z offset manually using the printer paper method. I tried to get what I thought was a decent grip on the paper and let it go. This isn't the end of the elephant's foot issue though, so we'll come back to it when I try and fix it. The next thing I did was E-steps. I don't have footage of doing E-steps because there are plenty of other tutorials out there that will teach you how to do E-steps for your extruder in all axes. I will hopefully link those videos in the description below. Let me know if you want me to do an E-steps video for some reason. I will probably just be restating information that's out there already, but if you'll watch it, I'll make it. One thing I will add is I used the 100mm test instead of the Chep cube to hopefully get more accurate results, and printed it 3 times to get the average. My E-steps were consistent across the 3 models, though the size was slightly off. The Z was perfect, but the X and Y needed a small adjustment. Though now that I think about it, I never actually went back and tested to see if they were corrected properly. One thing that wasn't mentioned on Reddit in the comment, or really ever actually, was calibrating the flow rate. In the video I used for calibrating the X, Y, and Z E-steps, the guy mentions in the beginning that he calibrated the flow rate, which I have never actually heard anyone recommend before. So either it's typically not an issue, or it might not be that important. It sounds like it would be to me, and I might look up how to do that in the future if I remember, but it wasn't done in this video. One thing that kind of threw off the entire course of the video was the discovery that I made while printing the XY of the E-step calibration prints. I thought this usually happens from the Z offset being too close and the plastic gets pressed too close and pushed out farther on the bed, which usually causes the problem. So I tried adjusting the Z offset between the calibration prints. The first print came out with bulging, so I raised the height by 0.07 or something like that. Then the print came out with a small bit of warping on the corners, so I lowered it by about 0.03, and it had elephant's foot on the next one. So like I said before, the video kind of falls apart from here, especially that I started to realize that these solutions are just different band-aids rather than actually fixing anything still. I tried doing the Z offset before this step, but looking back, if you can make this next step work, then it's probably better to do it before the Z offset. The next thing that was recommended was to basically manually level the bed and adjust the data points, just with a slightly different method than what I said in my previous video. He said to, and I quote, edit the auto level data and check each point using a piece of A4 paper. Make sure the grip of the nozzle on the paper is the same at each point. The more time you took, the better the prints. End quote. So So I have some issues and misunderstandings with this method. First of all, it's the same thing that I said before, just without actually printing anything. By the way, when I tried getting clarification, he mentioned that you should heat the bed for this process because of the expansion and all that. Now, I'm not upset because it's a better method and it's less wasteful than the one that I provided originally. I'd be glad and relieved to have this information. I just don't understand some of the basic principles of how to actually do it this way. One, you have to estimate the positions of the actual leveling points. There are ways to do this, like printing out the bed level test and using that as a template, or running the level test and trying to make physical markers of where it probed, but that's only half the issue. The other half is 2, adjusting the level data isn't a live adjustment unlike basic movement or Z offset adjustment. At least it's not as far as I could observe. So how are you supposed to make adjustments and see if they work without estimating the difference and homing the printer for the update after every adjustment? You can't use live movement because it only goes to the first decimal point for adjustment when the leveling data needs finer data than that. Are you supposed to move the head to the estimated spot, then go to the Z offset and find the difference? This step overall frustrated me and is where it ended for me, except I did the Z offset before this because I was trying to figure out that elephant's foot issue. Like quickly stated before, I tried to reach out for clarification, but the reply took a few days and didn't really help. I was getting so fed up with everything that I wasn't in the mood to try and clarify further and wait for the next reply. I did apologize for the late reply, and the next one might not have taken nearly as long, but I just didn't want to wait and deal with it all. So, like stated before, we're coming back to the elephant's foot / Z offset issue. The way the commenter recommended handling the Z offset is to print a single layer sheet across the entire bed and do the live adjustment as it goes. Now, if you do this method, you will need to do the manual bed leveling first because the typical regular data that it comes with will throw off the Z offset print entirely, most likely. But even then, I have some issues. I embarked on this journey after trying to get the perfect Z offset after I did my manual leveling. My manual leveling was pretty good, but once I tried setting a new Z offset, it threw the whole thing out of whack. I'm not 100% sure on how the Z offset and auto level data affect each other, but to me it seems like the Z offset is designed to take the height of the center of the bed and create a flat data plane from there. When you add the auto level mesh to that, it will make points higher and lower based on that one middle point. But if you change that middle point, you will take the entire mesh and move it vertically up or down, then resulting in some spots being too high and too low again. So with that long explanation out of the way, I hope you can see why I've been wrestling with the order of these recommendations. But back to what I did to try and fix the elephant's footing. I started by printing Chep cubes. This is because they are large and solid enough to show the elephant's foot clearly while not taking absolutely forever to print. I eventually shortened the time even further by having the Chep cube. I call it the Ep cube. Very clever me, thanks me. This will be available in the description. I have posted it to Thingiverse. The short version of this story is I kept raising the Z offset and it never really made a difference for some reason. I don't know if I needed to raise it even further, but by the last print I did, I checked the Z offset with the paper and there was no grip whatsoever, but there was still a major elephant's foot. So I was left kind of dumbfounded by this. I really didn't know why this was happening, and I still don't, because then I tried to fix the issue with the initial horizontal expansion setting using the relatively new Cura profile for the V3 SE. I started out trying to be conservative with it, but eventually I was using exaggerated settings just trying to see if anything would change. I tried doing a negative 1mm initial horizontal expansion, and it did leave the bottom looking a bit strange, but there was still elephant's footing somehow. At that point, I was at a loss, and I went to start working on the leveling data and found those other problems and got unbelievably frustrated and stopped the project just to think. Some afterthoughts is that calibrating that flow might fix this, but I really don't know. But other than that, I never fixed the elephant's foot issue, and I don't know how to fix it because most of the videos out there say the exact same things, and none of the suggestions work. So where I'm at now is trying to do a warranty claim through Creality, which so far has not gone well. I'm just so frustrated at this machine, and there are a few things that can be wrong, but I just can't find them and figure them out, and I just wanted something reliable, which I thought this is what this printer would be reliable, but it's not. An additional physical issue that I'm not completely sure about is that my print head seems to be completely tilted to the left a bit under the housing. If not the entire head, then the metal bracket holding the leveling probe, because that was definitely tilted. I messaged Creality support about it, and they got back to me the night after, messaging me back to provide them with a bunch of evidence, basically that I purchased a printer and that I deserve a warranty claim. I provided them with the Amazon purchase image. They asked me for a serial number with a barcode on it. They said there's supposed to be a sticker on the outside of the printer showing that stuff. Well, there isn't. But there is a QR code with a bunch of letters and numbers, so I asked them if that is it, and sent it in my email anyway because I didn't want to wait. Then I made an in-depth video showing and telling them about all the things that I haven't been able to fix yet in the months of owning this printer. The video is posted on my YouTube channel, but is unlisted because it's not really useful for the general public to view it. The video has 1 view, but I don't know if that was YouTube being stupid and counting me as a view, or if Creality has actually seen it. It has been 4 days now, and I have received no word on what's happening, even though I have provided them with what they asked for to the best of my abilities. I'm going to follow up tonight and see what they say, if they say anything. So that's how this video ends for now. I know it's not a helpful or even satisfying conclusion, but it's what happened, and this process took a long time. So I'm posting this and sharing it with you because I think that it's just reinforcing that there are some things that are seriously wrong with this printer. I don't know if it's the entire line of printers or the production of them, or if I just have had extremely bad luck, but as stated, I haven't been able to fix the printer and it's been months. So I'm just hoping that Creality will pull through on this one and actually help me instead of giving me another crappy band-aid solution to temporarily fix it. Because the way I see it, this thing is royally fricked. When I contacted support about the firmware not updating, they just plain gave up. They make it really hard to remember the human, but they give me so many NPC-like responses that lead to nowhere. It's just so frustrating. So if you're frustrated like me, consider leaving a like and subscribing for more music and 3D printing related content. There's simply nothing productive left for me to say, so I'm just gonna say bye-bye.